Good.
All right, awesome. So, everybody, welcome to Alvaro's talk. This is Alvaro. He is a veteran blue stamp engineering speaker. He started talking with us in 2012 in Houston, but he's since come to New York, Palo Alto, and San Francisco locations. So he's very familiar with what we do and how we do it. Number one fan. Anyways, he's a firmware and electronics engineer. He does a lot of the same stuff that I do, that I've talked to the morning group about, but basically designing electronics, writing firmware to go on it, and doing very similar stuff to the things you're doing. I'm not sure if you got a chance to check out his LinkedIn profile or whatever, but I would encourage you to interrupt him and ask him questions about anything, but there's a ton of cool projects that he can talk about, and even beyond that, he can talk a lot about how he got into where he's going and what he's up to. So with that, I'll hand it off.
Okay. All right, so yeah, I totally didn't prepare, but I have talks I've given in previous blue stamps, so I'm just going to ask you guys what you're more interested in. I have a talk about kind of how I became an engineer and some of the jobs I've had. I have one about projects and kind of lessons learned from learning. I was making robots that was shooting lasers at things for a contest. And then I also have one about making cheese and making circuit boards to control my cheese aging cave. So I don't know what you guys are more interested in. Feel free to.
Robots with blades.
Robots with lasers?
Yeah.
Okay, is that?
Project cheese. No,
You like cheese?
Yeah.
All right, I'll just do a hand. So like robots with lasers.
You have two hands up.
Cheese. Okay, I'll show you the cheese stuff at the end. I'll show you at least the boards I made. And this is kind of like 2 years out of date, but whatever. Let's see if I can use my phone to drive this. They're not. Oh, yes, I can. All right. So, why do I do laser shooting robots? The real reason is like, why not? I was, in 2006, I just turned 18, I had graduated from high school, and I found out about this conference, actually I'm wearing a shirt called DEF CON. Has anyone heard of DEF CON? No? Yep, one person, okay. It's like a computer security or hacking conference in Vegas that happens every year. And that's been a hobby of mine, if you will, and I found out they had a contest. It was called DEF CON Bots. And back then, it was a BB gun, autonomous BB gun that would shoot at these targets, totally on its own. So build an autonomous robot and write software to aim and shoot at the targets. Oh, actually, let me go back. The first one, the first one was a BB gun, and so I did this when I was 18. I had no idea what I was doing. I used my dad's webcam. I used a webcam mount for like the moving, and this is this thing is a Parmesan cheese container that's holding the BB. So this is very old. Fast forward till 2013, I guess, they redid the contest, but with laser beams instead of BB guns, because it's a little bit safer. The casinos weren't super excited about having BBs all over the floor and people getting hit. All right, so disclaimer, I have no idea what I'm doing. I'm an electrical and firmware engineer, but a lot of this project was mostly mechanical. So it was kind of, you guys, I'm sure, are doing some mechanical stuff or something that you might not be an expert at. So I'm going to kind of tell you real quick what my progress was building this laser one. So first, I had this balsa wood, and I just cut it with an X-Acto knife. I have some servos, and then I mounted a webcam on top, and then I had a little laser taped to it. So lesson learned is the servos are really easy to use, but once you are shooting a laser far away, any tiny movement gets amplified, right? Like, so the hobby servos were okay, but these targets were kind of far away, so it wasn't going to work great. I started scheming, like, oh, maybe I can use some gears or pulleys and use stepper motors. I started playing with laser cutting back at when Tech Shop existed. So I could rent some time in the laser cutter, so I started playing around with how to mount the laser. Lesson learned there, which is if you ever use a laser, do you guys have a laser cutter over here? You do?
We have a CNC.
Okay, well, close enough. But if you can use a material that's in a CNC softer, like paper, all the mistakes, all your screw-ups, do them on something cheap and easier, and then you get to do this. I started playing with pulleys and belts and stuff. Put the webcam on that. And then I learned that these things are much more complicated than I thought. Because you have to calculate the distance between the two and how wide they are, and then you have to get a belt that's just the right size, which I could never do. But I found out that I can just cut the belts and super glue them together, and that turned out to be good enough. I started increasing my design stuff with laser cutting, so I started designing it. Laser cutting is fun. I don't know if you can tell the difference between the laser cut one and my home built one. But yeah, it was basically what I did. I just learned how to use some 2D CAD software and was able to laser cut this. I got this one, which actually had motors, and actually has stepper motors, which kind of, you can tell it moved one like a few degrees this way or that way. The main problem I had with this one is this motor was too heavy to carry its own weight, so it didn't really work. It just kind of fell down and stayed down. So, yeah, things you learn. I started playing with laser cut gears, which was kind of cool. There's some software, you can just type some parameters and it'll generate the files to cut the gears. Normal gears are pretty expensive, but you can make some good enough ones with either a 3D printer or a laser cutter, which was kind of cool. I didn't know that. So here you can see some prototypes with just bigger motors and some gears. Up to this point, I've been winging it, just kind of making stuff up as I went. Once you start playing with gears, you start have to do more math because you need to know, how deep these are and like how many teeth you need to have and whatnot. But it was almost worked. So this guy would tilt the camera up and down, side to side, and then we just put the laser on top. Do you guys have stepper motors in any of your projects? Yes?
Yeah.
Okay, so do you know about micro stepping?
Yeah.
Okay, yeah, so stepper motors, you can basically send a pulse and it'll move one step, and usually it's like 1 point something degrees. A lot of new controllers, you can do micro stepping, so you can move less than the resolution of it, which is great, but if you have some load, it's not guaranteed to happen. Like if you send a micro step, it might not actually happen, so you might not know where your device is anymore. After that, I decided to learn 3D CAD, which I had never done before, and I was like, all right, this seems interesting. So I started modeling, and these are actual gear motors. I did some more laser cutting, figured ways to mount the webcam. I found out webcams are not good for mounting for precision. They're usually great for, it's like this tripod, right? You can kind of position it a certain way, but if you want to have the laser and the webcam always pointing in the same direction, it's kind of tricky. Anyway, I ended up with this guy, which actually uses these friction drives. So you have this circle there, and then you have these toy car wheels that move this kind of plate around, and then the pulley would move this up and down. I don't know if you can tell the main design flaw here. I would turn this on, and the whole plate would just fall right off, which I didn't realize until I built it. So, also use limit switches. You guys know what limit switches are? No? Okay, so the main problem here, even if you were able to turn, I have all these wires, all these cables. And my motor doesn't know that the cable's going to get tangled, so if you just tell it to run, it's just going to spin until it rips itself apart, which it did a few times. So I have to add these switches that basically, when it would move this direction or that, it would tell the microcontroller to stop. I then decided to make it more complicated, so now it's kind of a cross. And I learned that super glue and epoxy are pretty great, because I was able to laser cut these parts that were too big for the laser cutter, or like the piece of wood I could get, so I just did the pieces and I used epoxy to glue everything together. Let's see. So here you can see kind of the previous generation you saw, and this is the newer one that actually has 4 of these wheels, so it won't fall out. This is just a different angle. Oh yeah, always build 2 when you're going to a contest, because it will break right before. So having spare parts or an entire spare device, it's kind of great. This is what they actually ended up looking like at the contest. I got a different webcam, I took it apart and just glued it in, and then I would shoot these targets. Oh yeah, when you're using this friction drive that I mentioned, the wheels would sometimes spin, so I put rubber bands around this to kind of add a little bit of friction, which is kind of cool. Here's another picture, the webcam with the little laser. Okay, so anyway, we went to this contest. The targets were a little train, so it's a little train track with ping pong balls on it. And you have this train, model train, just running around with these ping pong balls that you're shooting with a laser. We got first place that year, which was kind of cool. Most of the other robots didn't work, but still. So then the following year, they said, hey, let's make it more complicated. Let's make the trains get moving faster, and now not only do you have to shoot these targets with a laser, you have to encode data in the laser saying, I'm shooting at target 3. So now your thing has to be actually intelligent. And I thought, since we had one last year, I want to make some changes just to learn something new. So I started playing with galvanometers, which are these guys, and it's just mirrors. This is kind of a device that it's like a motor, but it doesn't spin completely. But it lets you move the mirror very precisely in very small increments. So since you have these 2 mirrors, you could basically shine the laser anywhere, and you can draw stuff on the wall, and all that cool stuff. And yeah, it's a ton of fun. I was able to draw vectors on the wall and all kinds of stuff. To start, I ordered this laser show thing from eBay, and I would just clamp it down. And I found out that precision mounting optics is really hard. If you look at the university labs, they have these huge heavy tables with these screw mounts and all these things, because any tiny movement will throw your laser right off. So I learned about this open beam, which is kind of these extruded aluminum. It's not quite Legos, right? But it's kind of cool. And I did some more laser cutting and whatnot, made some mounts for it. And this is what the last robot ended up being. So you have the laser shooting at this mirrors here, and now the camera's static. Yeah, open beam is awesome. Here's from the rear. These are just the drivers for the galvanometers. Just different designs. It's my old living room. We had the black cloth here, and then the ping pong balls we'd shoot at. So that's kind of what it ended up looking like. I had to make some electronics for driving the laser, because I had to encode data in it. This is just more technical, but I had an analog circuit to drive the mirrors. And I had to go from a digital to analog converter, and then you have these resistors that tell you how big the gain is. And my math never worked out, so I used variable resistors instead. It's great. If you ever have an amplifier of some sort, and your math tells you use this kind of resistor, consider putting a potentiometer, which is like just a variable resistor, because then you can tweak it instead of having to resolder, and it's just a pain. So yeah, this is how I have to go pack to go to the airport, because the TSA doesn't like robots or weapons of any kind in your luggage, so that was fun. And yeah, this is in Vegas. I mentioned always bring spares, and here it is at the competition, shooting the little train thing. As I mentioned, something will always go wrong, so yeah, bring spares, plan ahead. Okay, so that's that. I don't know how much time I have, if I can show you guys the cheese stuff real quick. This is talk I gave it. Oh, quick question.
Did you win?
Not the second year. We had some issues transmitting the data. So the lasers were hitting the targets, but the data wasn't making it, like that I'm shooting, probably because of the mirrors. So it was kind of degrading the laser beam. So we got second or third place, I think. But yeah, it was a ton of fun. I learned a lot. I mostly do this to learn, because it's just a lot of fun. So this is, I'm just going to jump to some of the slides that have the circuit boards I made. But I gave a talk at a conference a couple months ago. Basically, I like making cheese. And so I learned how to make brie. Does anyone know, like brie? Yes, all right, awesome. So I'll do real quick cheese making lesson. You get milk, you get peltries, you have molds and all sorts of stuff. You get the milk warm, then you add rennet, which coagulates it, and then it basically turns into like gelatin. You cut it, then you put in these molds, and then you put in these molds, and it kind of, the whey, which is this liquid, kind of drains away, and then it ends up looking like this. And then you add some salt a couple days later, and then they look like this. And then this is not my house, but this is a more professional aging environment. So once you have that, you basically age it for a while. I made a little fridge where you can put, I have temperature and humidity sensors to age these. And this is a little time lapse of mold growing on brie. So the bries have a white crust, or white kind of rind, because it's actual mold that grows on it. And this is like not bad for you, this is good. And then you wrap it, and then you wait, and then you have brie, and I made this. So because of this, I wanted to make some circuit boards to make the cheese. So I ended up making like a controller that can connect a bunch of different boards, and then I made it smaller, and then I made it smaller, and then eventually I wanted it to kind of look like cheese. So I was like, oh, I'll make cheese wedges, right? So this was my little cheese board controller. This took like 6 months, just of iterations and stuff. And this is a microcontroller that controls the temperature and humidity. Oh, well, it monitors the humidity, controls the temperature of the fridge. And then these little cheese wedges are temperature humidity sensors, so you put next to the cheese so you can keep track of how that all works. And eventually, like with Bluetooth on it, because why not? Yeah, so this is just. I had a bunch more stuff about the electronics of it, but I just wanted to show you guys real quick that. And I just remembered I do have a video of the robot working from a different talk I gave. Let's see. So this was a little video I played because have you guys been to Maker Faire or know what Maker Faire is? Yes. Okay. So. Oh, awesome. Yeah. That's the reason I moved to the area. Basically, I came to Maker Faire and then met a bunch of people. But I made a little video showing kind of the robots, since it was going to be at Maker Faire. Oh, there's speakers. Anyway, I'll just let you watch. This is the first version, and then that hand cut one. And yeah, I was doing computer vision and whatnot. You guys are curious about that. So that was just me testing the robots at home, shooting the lasers and stuff. It's probably more interesting than just the pictures. So at Maker Faire, I made this kind of shooting gallery that you could compete against the robots. So you could have a laser pointer shooting the robot, shooting the targets, and then the robot would be next to you shooting. And so that was this thing. This is just humans playing against each other, but I also had the robot shoot. Yeah, we made sound effects at Maker Faire. We just asked people like to make pew pew sounds and recorded them because we kind of made it the night before. Anyway, that's that. Any questions?
Seems like you're kind of into automation. Like, do you think you'll do like more with that like in the future? Like, do you see technology going there more, or?
I mean, for manufacturing, that's been the case for a long time. I'm very interested in automating stuff at home or like smaller scale stuff.
Yeah.
I worked at a company making satellites a few years ago, and a lot of what I did was automating all the tests to make it easier and faster to test all the circuit boards going to satellites and stuff. So yeah, I'm a huge fan of automation.
So you showed us like a few clips of the robot, the laser shooting robot.
Yeah.
Like really anything right now.
Right now, I'm still working on the cheese cave control, like the cheese wedges and whatnot. I've been making a lot of cheese. I'm also making a little weather station for my dad, just for fun, to learn about different sensors and solar power and all that stuff. That's mostly what I'm working on.
Your laser gun thing, it reminds me a lot about it reminds me a lot of like the laser gun that just came out that our US Army is using, that was like just created, and it's almost exactly like that. Like it senses stuff and then it just hits it with a giant laser.
Yeah.
And it explodes.
Yeah, no, those are a little bit bigger lasers. I think they just melt whatever they hit kind of thing, which is super cool, but scarier. The green laser was scary enough that if it hits you in the eye, it could do some damage. But I had my laser goggles at home because I did most of the testing in my bedroom, so I didn't have much else to do it.
When you're making stuff like this, do you make your own PCB boards, or is it kind of you use what's already out there and it's like a combination of both?
A combination mostly. So I'll usually start with a development board. So the companies that make the microcontrollers usually have the little development boards that are pretty cheap. So I usually buy those and use those. They're like $30 or $25. Once I want it to be like this particular form factor, or if I need other features, I'll start making my own. Yeah. But I heard Oshpark earlier, and I use Oshpark to make my boards all the time, even at work. Yeah. Any other questions?
Yeah, that about wraps up our time.
Awesome.
Let's all give Albert a round of applause.